Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by AWS and Datadog. My name is Cody, and I'd love to welcome you back to Techstrong Learning for yet another exciting program. Before we get things kicked off, I do have just a couple of housekeeping notes that I'd like to cover with you. First of all, today's session is being recorded. So if you miss any of our conversation, perhaps you'd like to rewatch at a later time or share with your team, you will be receiving an email with a link to access the recording on demand. Now, if you'd like to engage with us today, there are a couple of options for you to do so. The first option is the chat tab on the right side of your screen. And I'd like you to go ahead and start testing that out for us by letting us know from where in the world you are from. I'm seeing Colombia, Texas, Mexico City, Scotland, Canada, California. So let us know. I know we've got a global audience. If you do have any specific questions, though, in order to help us stay on track, help us keep everything nice and neat, send those questions into the Q&A tab. Sending your questions into Q&A just helps us get to them as quickly as we can and keep track of which ones we've already answered. So again, send your questions into the Q&A and we'll hopefully address them towards the end of our program today. If you click the polls tab, you'll note, or sorry, not the polls tab, the handouts tab, excuse me. The handouts tab has some additional resources for you if you'd like to go ahead and grab those. And of course, before we close things out today, we're going to give away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our conversation today. Our topic is building and monitoring serverless apps with AWS and Datadog. And I'm joined today by Antara Raisa, Partner Solutions Architect at AWS, and Rory McCune, Senior Advocate at Datadog. So Antara and Rory, thank you both so much for joining me today. Antara, would you like to take us into these slides?
Yeah, I can do that. But first of all, thank you, Cody, and to Techstrong Learning for having Rory and I to present on AWS and Datadog's capabilities around building a resilient serverless architecture and monitoring. So with that in mind, just a brief glimpse into the agenda. First, I will be covering an overview of some serverless architecture patterns, followed by some of our services that can help support that. And then Rory will be taking it over with doing an intro to Datadog, talking about some of the new Datadog serverless features that are coming out and the landscape development around that. And then we will conclude it off with a demo. So with that said, first, let's look at some of the serverless architecture patterns. And this basically means a way to build and run applications and services without having to manage any infrastructure. And this approach really helps you and your team focus on the actual business value and add a lot of value and forget about the infrastructure management part. So to do that, first, we're going to look into an event-driven architecture. To do that, first, let's look at what an event is. An event is a change in state or any update, like, for example, an item being placed in a shopping cart on an e-commerce website. So events can carry the state. For example, if you buy an item on that e-commerce website, the item purchased, its price, or a delivery address, or events can even be identifiers, a notification that the order was shipped, for example. But with these events help us trigger these services. So in a serverless architecture or an event-driven architecture, services are triggered by events that occur in the infrastructure. And events may be a change in state to an order, going back to the example I gave previously, that it was placed on that website. And in the event-driven architecture, events are used to trigger and communicate between decoupled services, and it is common in modern applications built with microservices. In an event-driven architecture, there are 3 key components. First, you have event producers, event routers, and event consumers. A producer, like the name suggests, publishes an event to the router, which filters and pushes the event to consumers. Producer services and consumer services are decoupled, which allows them to be scaled, updated, and deployed independently. Rationalizing your serverless architecture requires you to think about the event sources and how serverless functions can be activated. Events can also be asynchronous, so you don't have to wait for the response to move on to the next step. And this also helps improve resiliency and reduces dependencies. And the tools of the event-driven architectures can help you abstract producers and consumers from each other. And then using those concepts in mind, you can really look to using different services to help you build that fully fledged event-driven architecture that we have in mind. So that was just a brief glimpse into what an event-driven architecture is, but let's look at how we can use that concept to build a modern application that is serverless first. And this is a strategy that prioritizes the adoption of serverless services so you can increase agility throughout your application stack. So for that, let's look at why serverless is being adopted so readily. So it's growing very fast because the serverless strategy enables customers like you to focus on things that benefit you and not on infrastructure management. So for example, getting to market faster and delivering features, or even performance and scalability. With the pay for value and the lower total cost of ownership, serverless services really enables customers to focus on business value. And this is really the reason why customers are adopting a serverless first strategy, and it helps align with what you're looking for and find the areas that you want to focus more for investment. With a serverless strategy, we have small pieces that become loosely joined. So one thing that's common across serverless application is that they follow the design idea of the internet and the web. So small pieces loosely joined, and all of these applications are modular and composed from multiple AWS services that customers developed and those components. That's why we are so focused on delivering lots of integrations in some of our services like AWS Lambda and Event Bridge and API Gateway and Step Functions. And those are some of the services that we'll touch on later. But we want to make it easy to build new applications and functionality through loose coupling with other components. So with that, let's look at some of those components. So serverless goes beyond compute. You can have many different serverless services. So for example, in the compute space, you can have something like Lambda, which is a compute service, or Fargate, which uses containers. We also have serverless data storage options like Amazon S3 or Amazon Aurora Serverless, which is an on-demand auto-scaling configuration for a service we have called Amazon Aurora. And it is a database service that lets you run your database without having to manage any of the underlying instances related to that. Things related to integration. So for example, Amazon Event Bridge or SQS, which is our simple queuing service, can help you really decouple your monolithic architecture and build a serverless first strategy. So I mentioned a lot of those serverless services before, so I wanted to show you a spectrum of where a lot of our services fall, and this is with the AWS operational responsibility model, where different services falls on different level, where different services have different levels of maintenance that is required from you as the end customer. So for example, if we go to more and more managed services like Lambda or DynamoDB, which is another one of our database offerings, then the responsibility on AWS falls more where we are responsible for all of the underlying infrastructure, and you don't have to worry about things like patching or maintaining those instances. Whereas if you look more on the left side and you look at some of our compute and database offerings, so for example, Amazon EC2 or MySQL for Amazon EC2, those give you a higher level of control, but along with that comes the responsibility of having to patch and update those instances as they come along. So with a serverless first with a serverless first strategy, you can focus more on using services like Lambda or DynamoDB that really give you the peace of mind, and you don't have to worry about having to maintain all of the underlying servers. I've mentioned Lambda, so I wanted to take the next couple of minutes going into what AWS Lambda is, which is our event-driven function as a service. And AWS pioneered the serverless computing space with the launch of AWS Lambda in 2014. And today, over 1 million customers are using Lambda to do just that. So what is AWS Lambda? Lambda provides the fastest way to build modern application with the lowest cost of ownership, and it is a serverless compute service that lets you run code without provisioning or managing servers. And Lambda runs your code on a highly available compute infrastructure and performs all of the administration of the compute resources, including server and operational system maintenance, capacity provisioning, and automatic scaling and logging. With Lambda, you are able to automatically scale up and down in milliseconds with demand, from a dozen events per day to hundreds of thousands per second. Lambda also reduces cost with the pay-as-you-go usage by per millisecond. And all you have to do to get started with Lambda is just supply your code to one of the languages that Lambda supports, such as Java, Go, Node.js, .NET, Python, Ruby, or bring your own. And with that, you can also benefit from Lambda's native integration with over 200 AWS services and other SaaS applications. With that brief introduction to Lambda, let's look at how Lambda works. So you start by creating a Lambda function, which is a piece of code that performs a specific task or implements a particular functionality. Functions in AWS Lambda are typically short-lived and stateless, so you can write your function code in a variety of programming languages like the ones I mentioned before, such as Python or JavaScript, Java, C#, and more. And fun fact, as of November 2022, we also released a new feature of Lambda, which is called Snap Start for Java functions. And AWS Lambda Snap Start for Java delivers up to 10 times faster function startup performance at no extra cost. So that is a service, that is a feature of Lambda that we recently released that I thought was pretty cool. So with that in mind, this is the first part of how AWS Lambda functions work. Then we get to the event source. So Lambda functions are triggered by events from various event sources, and we touched on what events were previously, and these event sources can include things like API gateway request, a change in objects in an Amazon S3 bucket, or even updates to database records in Amazon DynamoDB, or messages from the simple notification service. Or you can even schedule time-based triggers using Amazon CloudWatch events. You configure these event sources to send events to your Lambda function. And when an event occurs from the configured event source, Lambda automatically triggers the corresponding Lambda function. It provisions the necessary compute resources to execute the function code, and then it invokes the function. The event data is passed as an input to the function, allowing it to process the event and perform the desired operation. Then you get to the third part where it integrates seamlessly with other AWS services. So you can leverage triggers and events from services like the ones I mentioned before. And those integrations enable you to create an event-driven architecture and connect your Lambda functions with other AWS resources. So for example, after executing the function, AWS Lambda captures the output generated by the function, and that function can return a response to the invoker or generate output that is stored in various AWS services, like writing that data to an Amazon S3 bucket, or updating a record on DynamoDB, or publishing a message to an SNS topic. And that function can also emit logs, which is stored in Amazon CloudWatch for monitoring and troubleshooting. So just as a high-level kind of summary of what's happening with Lambda function, with where in this example, you are having an event source where this is something happens that is different from the original state, and that could be something being placed in a database or an S3 bucket. And that event triggers a Lambda function where it does some sort of compute. And then after that function executes, you can then connect to other services and either update that record or update logs and go on from there. So with Lambda, we also have 3 different types of execution models where you can have asynchronous execution of the Lambda function, and this can be either via the CLI or the SDK, or with the newish function URLs, or through a service like API Gateway, which is mapped to a Lambda function. And then the request to the Lambda function does its processing and waits for a response before returning it to the client. The second is to invoke the Lambda function asynchronously, again via the client call, or maybe S3 change identification or services like event bridge sending an event when a rule is matched. And you don't wait for a response to that function code, hence why it's asynchronous. You hand off the event to Lambda, and Lambda just handles the rest. It places the event on an internal queue and returns a response to the core saying, yep, I got your event. And a separate process then reads the event from an internal queue and sends them to your function. And there is no direct return path to calling that service. And then we also have Stream, which is pull-based, and those are kind of the run-through of those. Another service I quickly wanted to mention alongside Lambda are AWS Step Function, which is a visual workflow service that helps developers use AWS services to build distributed application, automate processes, and orchestrate microservices and even create data and machine learning pipelines. So AWS Step Functions are a serverless orchestration service that lets you integrate with Lambda functions and other AWS services to build business-critical application. And through the Step Functions graphical console, you can see your application's workflow as a series of event-driven steps. And those step functions are based on state machines and tasks. And in step function, you can have something called a workflow, and that's based on state machines, which is a series of event-driven steps. And each step in a workflow is called a state. So as kind of the description on the slide shows you, we have this service that, to summarize, helps you with creating a serverless workflow and is offered pretty much in almost every AWS region, and helps you build using a state machine is composed of steps called states, and so on and so forth. I mentioned this briefly because later we will be going over how you can monitor these step functions along with Lambda. So we covered Lambda, we covered state functions. So I really wanted to focus now on what some of the top use cases for Lambda was. We started off very technical with diving deep into an event-driven architecture, then going into some of the nitty-gritty details of Lambda and its configuration. So I wanted to take a step back and make sure we are understanding what Lambda is used for. And we see customers using Lambda to build a wide variety of application with serverless building blocks, but a few things are common where they tend to see huge benefit. And the first is with IT automation, such as using Lambda functions to validate some configuration for each time an EC2 instance is launched, for example. Then we also see individual teams using Lambda to integrate with things like S3 or EFS to ingest, process, and analyze high volumes of data quickly and efficiently in data processing, or use Lambda integrations with things like Amazon Kinesis or Amazon MKS streams to capture streaming data. And those are two streaming services we have. So Lambda can be used to capture streaming data and then gather analytical insights and act upon them in real time processing for applications in IoT, for example. Then, usually, as experience grows, as you get more and more comfortable, we often see teams who start building whole microservices based applications, often for API based interactive web application to gain agility, reduce that operational complexity, and reduce cost and scale automatically. Finally, we also see Lambda functions used with some other managed services as a critical part of their event-driven application, where decoupled systems run in response to events to scale and scale independently and go with that. We also, I know machine learning is a very important topic right now. So we also see customers using Lambda in machine learning applications too. With that introduction to some of the AWS services we have, most specifically Lambda and how Lambda is used, I will pass it to Rory to introduce Datadog and hopefully do a really cool demo.
Hi, Antara. Great stuff. Thanks very much for that. I know I learned quite a few things about how AWS did serverless there. So what I wanted to do to start off this section of the webinar was to introduce Datadog a little bit, just in case people haven't encountered it before or don't know some of what we do. So what is Datadog? Well, our goal at Datadog is to solve complexity in your IT infrastructure. And the way we do that is to pull in information from all the different sources you might have, from applications, from networks, from servers, all the different locations, and bring that together into a central place where all the different parts of your business, so business management, IT ops, developers, can see the information they want and can work from the same set of information. And that hopefully helps you solve some of the complex problems you're going to have in a modern IT environment. Now, one of the things we need to do as part of that is obviously we need to bring in information from all the places that you're using. Now, a lot of people will use a lot of different services. And we've got over 600 built-in integrations. So these are ways of getting information out of a service into Datadog. And as you can see from the screen there, we've got a lot of support for various Amazon services, including a lot of the Amazon serverless services that we've been talking about earlier today. But when we're talking about serverless, we're talking about Lambda, ultimately what we're looking at is how do you run your applications? What sort of approach are you taking? And how do you need to monitor and manage and observe those platforms differently? If you take the kind of the original older world, you probably had physical servers. You probably had things like WebSphere. You probably had things like IBM. You may have had virtual machines. But you had lots of different physical servers. And there you were likely interested in host level metrics because you were managing the whole server for an application. You looked at what the host was doing. Then we moved on and containers came about, technologies like Docker and Kubernetes. And here, whilst you may still manage the underlying virtual machine, it wasn't tied to one application per VM anymore. The promise of Kubernetes is that you don't need to know exactly where your workload, your application is running. So our monitoring and our observability concerns and how we need to approach it changes. And then we move on to serverless, which is our focus for today. And obviously in serverless, here the underlying infrastructure, as Antara was saying, is completely abstracted away. You don't have any concerns with what a given host is doing. You're purely focusing on the performance, the management, the monitoring of your code. So again, what we need to do changes. And if I look at that and kind of say, how does that maybe work out? Well, in infrastructure, you're probably interested in physical location potentially, or what cloud it's in if you've got virtual machines. But you're interested in where your hosts are, and you're interested in the performance of those hosts. Those things like CPU, disk I/O, memory. But it's that host level is going to be a lot of your focus because you have to manage that and you have to monitor that. Even if you're an application owner, if your application is the only thing running on a host, you're probably pretty interested in what that host is doing. So that's the kind of thing you might see if you're using kind of more traditional or older technologies. Then we move on to containers. And as we've said, with containers, you don't or shouldn't need to know what host your application is running on. So as an application team, your focus changes. And now you're looking at more logical organization of your services, and you're saying, what can I see, in terms of the performance, in terms of the errors that are occurring in a given service, without concerning yourself directly with that underlying infrastructure. And then as we move on, we get to serverless monitoring. And here again, there are specific concerns. And it's why it's so important that your monitoring and your observability tooling understand serverless, because there are specific concerns around serverless that you need to account for. You can see on the screen we've actually got up here that we've got an insight around cold start. And we'll talk about cold start a bit more as we go through. But just in case people haven't encountered this as a term before, a cold start occurs in a serverless compute environment when the first time your service has been requested in a period of time. And the execution environment that's needed for your application is essentially spun up. That's what's called a cold start, and it typically has some level of performance impact. So obviously, when you're monitoring serverless applications, it's important to make sure that you understand what that impact is and to be able to do any sort of optimizations to reduce it as much as possible. So you need to consider that part as well. In terms of what can you gather, what information do you need to run your IT infrastructure, to run your IT services and IT applications? We kind of see it as falling into three main buckets. First, you need metrics. You need to know things about the various way in which your application is performing. That might be CPU used, it might be memory used. There's a wide variety of metrics for you to gather. You also then want to try and provide visual representations of that information. And I'll look at one in just a second to kind of show you some of the things you might want to gather. Next up is traces. So when you're debugging an application, one of the first things you want to do is you want to say, well, what happened? What were the individual parts of my microservices application doing? So we're now talking about microservices, we're talking about serverless. You're not talking about one application doing everything in an old monolithic fashion. And as a result, you kind of need distributed tracing across all of your different services to really get a picture of what's going on. And then obviously, logs are going to be very important as well. You want to bring together all of your log information into one place so that when you're debugging, you can see it all in one place. And you can actually put proper context around that log information so you can understand what's significant and what's just noise. To give you an idea of what that could look like, here is a dashboard. This is a sample dashboard that we have for one of our demo applications. And it gives you an idea of some of the metrics you might be interested in. So you've got metrics around Lambda here. So the number of errors that you're getting from your Lambda is very important. How many of your invocations were cold starts? Latency is generally very important to businesses. And I know we've got a question in the Q&A about what metrics are important to your business. In a lot of cases, things like latency will be important to them because it's important that customers are getting back responses from your applications quickly. And there's been a lot of research into the idea that customers will move on if web pages load slowly. So obviously, knowing that your web pages are loading quickly and your customers are getting a fast response is very important. But you can also see from this dashboard, I think a good example of how in a serverless environment, you need to pull information in from lots of different sources and have it visible in one place. You can see here we've got Lambda, we've got API Gateway, we've got SQS. All of these things in one place allows you to say, well, if my application uses all these services, I can monitor end to end on one dashboard, which I think is a very powerful concept. In terms of traces, well, obviously when you're trying to debug your application, you need to actually go into the code. And here, one of the things that Datadog focuses very heavily on is being able to let you look inside the code to see what's going on. You can see the trace on the screen, which has got an error. And you can see all of the different parts of the flame graph there, showing you where there are errors in the code. And you can see the detail of the error as well. So having all that information visible straight from your dashboards is going to help you a lot when you're trying to debug a production issue with your application. And then logs, again, logging information, super important because logging information tends to be under your control. You can log anything out of an application you want, but you're going to want to have all those logs brought together in one place. Again, coming back to this idea of in serverless, we're using distributed microservices. We can't just go to one host and start tailing logs. We need to have some way of bringing all that log information into a single place so that we can see it all in one place. And that's something we've got a lot of services for there as well. So obviously, the serverless world is quite a fast-moving world. things change. And Datadog has been bringing together quite a lot of new features and functions related to serverless. I just wanted to talk about a couple of them, which have just come out recently, as I think they're kind of pretty useful features to have. First one is cold start tracing. So I've mentioned already the concept of cold start and the idea that cold start is something that when you're developing serverless applications and serverless services, you're going to be interested in. What impact are cold starts having on your application? Now, it's slightly dependent on your kind of application you're using as to how much impact this has, but it is very useful information. Datadog has always been able to give you an overview of what the impact is in terms of the time of the cold start. But with the new cold start tracing feature, what it actually allows you to do is dive into the individual functions that are happening during the cold start and see what time impact and the performance impact is of those libraries. And I'll actually show this a little bit in the demo at the end. It lets you see how easy it is to actually kind of dive into a cold start and say, actually, you know what, this library is what's causing my problem here. I can maybe look at not loading it or find some other way of keeping the Lambda warm so it doesn't have to do a lot of cold starts. But that's a new feature we've got fairly recently. And then the other thing is, this is currently in beta, but it'll be out fairly soon, is AWS step function tracing. Now, Antara mentioned early on, step functions are essentially an orchestration service for serverless functions. And when you're orchestrating a set of Lambda functions together, it's very useful to be able to see them all in one place, right? Because if you've orchestrated them and said, my service is made up of half a dozen Lambdas bundled together into AWS step functions, being able to see that all in one place is very useful. And that's something we've added fairly recently so that you can actually kind of visualize and monitor your step functions all in one place. So another thing that I think is very interesting about serverless is quite how fast it moves as a landscape. You know, serverless changes quite a bit. And one of the things we do every year is we do a state of serverless report. And the idea of the state of serverless report is that it essentially analyzes all the data that we gather from customers who are using serverless and then provides information on trends. Now, as it happens, coincidentally, our new state of serverless report is due out tomorrow. So unfortunately, I don't have that URL for you today. However, if you keep an eye on our socials, I believe that URL is coming out tomorrow, so you'll be able to dig into the whole report. However, I was able to go into the draft report and pull out a couple of the facts that we'll be talking about in the state of serverless, and I've got them for you in this webinar today. A little bit of a sneak peek, you might say. So the first one I wanted to talk about, because this I thought was quite interesting, and I know Antara mentioned it as well earlier on, is about the kind of languages that people use when they're writing Lambda functions. So Node.js and Python were obviously the original languages that you could write Lambda functions in. And unsurprisingly, as a result, they've been the most popular. What we've seen this year is that that is to an extent still true. Node.js and Python are definitely still the most popular. But you can see what I thought was interesting about this particular fact was the rise in this custom bar. So you see after Golang, we've got custom. And this is custom runtimes, which are available now in Lambda and allow you to run any language you want or to run different languages and bring those into Lambda. So it's not just Node.js and Python. So for example, if your organization is a Rust user and you're very keen on Rust, it's now possible to use Lambda and actually use Rust as well. And that we can see that's becoming an increasingly popular option as we sort of see the number of Lambda invocations using custom runtimes rise over time. So it's kind of interesting to see how that landscape is changing. And the other thing we've got is we've talked quite a bit about cold starts because it is quite a big topic when you're talking about performance monitoring of Lambda. We looked at what impact the performance on performance a cold start was. And we looked across the three major languages that are used in Lambda. And what we saw was Python was the shortest, and then Node.js was about 1.1 times more, but Java was 2.7 times more performance hit from a cold start on average. And that's kind of interesting because it says, well, there's obviously more going on in Java when you're loading things up comparatively to Node.js and Python. But I thought it was also very interesting what Antara was saying earlier on about SnapStart, because SnapStart has obviously been designed by AWS to address exactly this problem, because it allows you to speed up your initial invocation of Java Lambdas. So that's an interesting point. If you're using Java Lambda, it kind of says you can see exactly why you should be using snap start, because you can see there's quite a large performance hit from that initial cold start. But interesting as well to think that, if you're designing your Lambdas and cold start is important to your given application, it's important to think about what language you're using, because the performance hit can be different. So what I've done now, what I did there was talk through a little bit about how Datadog does its monitoring, some of the features that we've got that you can use to monitor, manage, and have observability on serverless applications, a bit about some of our new features that are just coming and launched, and also a bit about the landscape. But what I wanted to do now was really talk a bit about the detail and actually show you a quick demonstration to kind of show you how this works. So when we're monitoring and instrumenting a serverless application, there's essentially two sources of information that you're going to have and you'll be pushing and viewing in Datadog. The first one is you need to install a Lambda library inside your application, inside your Lambda. And that's designed to get information from inside the code. So when we were talking about serverless, one of the things we've been saying is, you don't have to have responsibility for the underlying host. But it's also worth saying that you don't have any access to the underlying host. So host-based monitoring isn't really an option. You need to be monitoring inside your code. Also, to get the best granularity of information for things like debugging and performance, you want to be monitoring inside your code. So the Lambda library is available for all the major languages that are available on Lambda, and that will give you your traces, metrics, and information. And then that will be placed into Lambda extension and pushed to Datadog. The other thing you need when you're monitoring serverless applications, and Tara was kind of explaining this quite a lot in her section, was you don't typically just use Lambda. You're going to be using Lambda plus an array of other AWS services. And here, the information you're going to need is logs. So logs are shipped to CloudWatch, and then Datadog has a forwarder which subscribes to your CloudWatch logs and then pushes that into Datadog. So you get the log information from all your different services, the metric information, the trace information from your code, and all of these are sent to Datadog. So what I wanted to do was just kind of show you a very simple example of this. What we've got is a simple serverless application. There is an API gateway endpoint, which has a URL. It sends a request to an entry function Lambda, so a very simple Lambda. This then sends a message to an SNS topic, which goes to an SQS queue, and then on to a consumer function Lambda. Fairly straightforward, but allows us to kind of demonstrate what's going on. An important point to mention here is that the code for this is available publicly on GitHub. So if you'd like to try this out, all you really need is an AWS account in which you have got the rights to create these objects, and also a Datadog account. And I'll mention it now, but I'll mention it at the end as well. You can always sign up for a Datadog trial for free. There's a URL link in the handouts, and that's a 14-day free trial of all of our features. So if you want to do something like this, get a Lambda application, spin it up, and actually monitor it in Datadog to get a kind of feel for what's going on, you can do that all for free, essentially. So it's a really nice way of kind of getting more experience. So when you get this, just to kind of explain how to do it, I said the code is available on GitHub, and you'll see in the README just at the bottom of the slide there's a launch stack button. This is a CloudFormation stack. So you can just click that button, and what it will do is it will take you through into this CloudFormation quick create stack page. To get started with it, all you need to enter is your DD API key. So that's your Datadog API key, which is available in all the free accounts. So you can get that one once you've signed up for your free account. And then you have to tell it what site you're in. By default, that's probably going to be datadoghq.com, which is the US instance. And I could have actually kind of run through this live in the demo, but it does take a couple of minutes to go through the CloudFormation startup process. And I thought we probably don't want to be sitting watching a CloudFormation screen for a while. So what I did was I got what I've kind of spun up in advance. So let me switch to my screen. And hopefully what you're seeing now on the screen is you're seeing a Datadog window. And you can see here we are in the traces section for our serverless sample app. So this is going to show us all the information for our sample application. Now, what I've got here is the URL, the API gateway URL. And I'm just going to refresh the page. And you can see, actually, if you're watching closely, that took a couple of seconds to restart. And then I'm just going to restart it a couple more times. And each time that's actually sending to API Gateway, through to Lambda, through to SNS, SQS, and then Lambda again. And then what we'll see here is, actually we see it already, we see our information coming through. This is all the information from the Lambda and from the other services being pushed back into Datadog. So let's actually dive into this and have a little look at it. Here is our initial function invocation. And you can see that it took 475 milliseconds in duration. And if I click into that, we can have a look at the detail. So what we can see here is we've got our Lambda function and we've got our SNS command and SQS over there. But what you can also see on the left-hand side of this flame graph is you can see our cold start. Now, if I double click on one of these, it'll drag us across into our cold start section. And here you can see exactly what we were talking about with cold start tracing, which is the impact of the cold start on this function. And it will actually dive all the way into how that was set up. Now, in this case, there's not a lot to this application. There's not a lot going on. And the only real thing it's loading actually is Datadog itself. And also it's loading Boto3, which is a library that's used to integrate with AWS services. But this, as you can see, lets you go all the way into the individual function calls and see what performance impact they're having. So if you've got an application where you're concerned about cold start performance and you really need to find out what's going on, this is a great way of doing it because you can dive right in there and actually work out what's going on. So if I go back to the main screen and I look at one of the other invocations. So here we've got a different invocation. We have got the second one. And what you'll see here is it looks very similar, except for the fact that there's no cold start. So this is exactly what we talked about earlier on with Lambdas, where we said cold start only happens the first time it's invoked in a period of time. You know, these things, they go idle after a while. But once you're invoking it regularly, so if you've got a Lambda that's being hit a lot, you're not going to get a lot of performance impact. You just get it once, and then away it goes. But using Datadog, you can actually get that kind of fine-grained information about exactly what's going on with your Lambdas. So let me go back to the slides. In terms of getting started, there's a couple of resources that I wanted to highlight. The first one was, mentioned this a couple of times, you can sign up for a free trial, 14 days, full functionality. You just need an email address. There's a link in the handout section. So that's available for you there. The other thing I wanted to mention is that we have freely available interactive training labs that cover a lot of our products. Specifically, I'll mention that we have an introduction to AWS monitoring course now, which is a new one we just fairly recently released. And that will be very useful for you because it covers things like Lambda in there. That hopefully be very useful for you if you want to learn more about how you can monitor AWS services using Datadog. And I'll pass back to Antara for this next slide.
Thanks, Rory. You can also continue your AWS serverless learning, and you can do that at your own pace by going to AWS Skill Builder. You can also use some of our ramp up guides to build up your own serverless knowledge, and you can also earn your own serverless AWS badge to demonstrate what you've learned, and it is a digital badge. And by scanning that QR code, you can actually go to a lot of the AWS resources we have around this topic and go from there.
Awesome. Well, Antara and Rory, it looks like we've got a couple of questions to get us started. But for everyone in the audience, please send in your questions and we'll be sure to answer it right now live on air. So let's just go ahead and take them from the top, guys. For the demo tracing Lambda, is it possible to track a request from API gateway to SQS consumer functions? And I'll go ahead and put that on screen.
Yeah, so I guess I can take that one. Yes, the answer is yeah. You can hopefully see in the trace information we had there that the information that the trace will go through any functions that send logs to Datadog. So as long as the service is sending its logs to Datadog, either via CloudWatch or via traces and metrics, we should be able to get that information in there.
So our next question is, does Datadog offer services only just as a security as a service?
Service, yeah, we are SaaS. Yeah, we're a SaaS setup. I believe there is not any on-prem option as far as I'm aware.
So how can I connect my current Lambda application to the 14-day Datadog trial?
So what you would do there is you would get your you would go through our Lambda install process, and that should be fine. You just essentially redeploy to Lambda. So you obviously would need to redeploy because you're installing the application library directly into your code. So you enable Datadog essentially inside your AWS account, and that starts sending watch logs to Datadog, and then you have to instrument your Lambda, and then you deploy it. The only thing I would say about doing that with a 14-day account is make sure to remove the integration again when your trial expires. You don't want that code sitting around after it's no longer in use. Or obviously, if you convert to a paid account at that point, it's great.
Yeah, there's also a lot of resources online that walk you step by step how to go about connecting and monitoring your Lambda. I think I can send you a couple of links or put it in the chat too.
Awesome. Yeah, thank you for that, Antara. Moving right along into our next question. How about container monitoring? There could be several containers. They are in dynamic nature, scaling up and down. How would the alerts and notifications be handled for those scenarios in Datadog?
So essentially, Datadog is you can tag your containers. So you can say, for example, this container belongs to this service. And then the monitors and information for that container are attached to the service that it belongs to. Because obviously in things like Kubernetes, an individual container will come and go, but they all belong to a deployment, for example. So we would essentially be monitoring the deployment and say, here are the containers that currently belong to it. And any logs you ship from the container, again, will be tagged as belonging to a higher level object. That way, even if the container vanishes, you still have the information available and you can still tie it back to what the service was that it related to.
Awesome. Thank you. Looking at Datadog, what would set it apart or make Datadog more unique than some of your other competitors?
That's a difficult question because obviously there's a lot of different services in the observability space. I would say that Datadog has a brilliant history in being able to pull all the information together that you need. You know, we've got a very comprehensive set of integrations. We've got a very comprehensive service offering in terms of all the different, so if you've got a complex IT environment, you need to have the information coming from everywhere. It's not so useful if you've got like 5 different monitoring services because maybe they don't support everything you're using. And I think that's one of the things I think Datadog really has focused on and excelled at. But obviously, a full-scale competitive comparison in the monitoring world would take longer than we have at the moment, I think.
Yeah, of course. So can we export metrics using extensions in Datadog?
Yes, that's my understanding of that. I'm sorry, I wouldn't be able to give all the detail on that one. But yes, I believe you can do.
With AWS, can you instrument a Lambda with open telemetry definitions that could send metrics to Datadog?
We do support open telemetry. I am not sure of that exact case, whether we can get OTel information directly into Datadog. I would need to check and come back.
Awesome. So this one was kind of touched on earlier, and Antara, thank you so much for responding to it via chat. But let's go ahead and discuss it on air. Can you share some examples of how Datadog has helped identify and troubleshoot issues in serverless apps running on AWS?
Yeah, I just wanted to double check. Do you want me to expand on some of the answer that I already published?
Just kind of give us a surface level, and then if you have anything additional that you weren't able to type.
Yeah, so the example I gave you was for a use case with Zendesk, and we have multiple other case studies with AWS and Datadog working together to help with application monitoring. And the one that I gave you with Zendesk most specifically has to do with how Datadog was used to monitor Kubernetes-based environment in AWS. And what Datadog helped with was figuring out a robust monitoring solutions that integrates both with AWS and Kubernetes, because the existing monitoring tool that they had created a silo between the teams. So they needed a better collection of metrics, whether it be like utilization or being able to trace through it and be able to look at logs and figure out what's happening when, if there was anything wrong, be able to kind of find the root cause. That was all something that Datadog helped with. So that was one such example. Another example with a gaming customer that I know was very popular was helping with Electronic Arts, where both Datadog and AWS worked together for one of their applications called Dice, and they used that to monitor game servers and stress test beta launches for that too.
Yeah, I think the thing I would mention, really kind of bring out that is, I think this comes back, kind of highlights the point I was saying earlier, it's the value in being able to bring everything into one place. When you've got different monitoring silos, it's really difficult to like look across and go, is that problem related to this problem? When you've got the ability to bring everything into one place and see your metrics, your logs, your traces, it just makes troubleshooting easier, I think.
Gotcha. Yeah, absolutely makes sense. I'm going to go ahead and pop this next question up on screen, but I'll read it out loud as well. With Amazon Prime's experience of converting from Lambda-based microservices to a more monolithic approach, saving them 90% of operating costs, how do we evaluate when Lambda is the right approach or not?
Yeah, I think the diagram that I showed during the beginning part of my presentation really helps you evaluate what sort of compute infrastructure is best for you and what you're trying to achieve. So, for example, if you really want a higher level of control, more granularity, and you want to have a lot more ownership over a lot of your compute resources, then it makes sense to go with something, for example, like Amazon EC2 that gives you that level of control. And then we also have offerings like AWS Elastic Beanstalk, which kind of falls in the middle, or things like Fargate. With Lambda, it's really used for cases. It's used in a lot of cases, but really a lot of people find the best use for it when they can just upload code and let AWS handle all of the nitty gritty of the infrastructure, so they don't want to worry about services because Lambda scales as you go. So if you really just want some sort of compute service that does it all for you, and then you just want to focus on the business logic, that's when Lambda, I think, really shines, because it helps you invoke that function, does the business logic that you're trying to do, and then gives you the output.
All right.
I don't know if that correctly helped answer your question related to that.
Well, if it did not,
but if you have a follow-up, I can also.
Yep. Hopefully they'll follow up with us in the chat if they need to clarify further. I do want to express we are out of questions at the moment. So while we wait for any last minute questions to come in, I'll do a light gift card giveaway. And then I want to, Rory and Antara, give each of you a moment to leave us with any parting thoughts or words of wisdom before we close things out. So I'll give you just a moment to think on that and give away our 4 $25 Amazon gift cards. Our winners are Manjula R., Roxana C., Sykarthik S., and Gregory C. So to our 4 winners, keep an eye on your email inbox to claim your gift card. We should contact you in the next 48 hours. If you don't happen to see an email from us, check your spam folder just in case it happens to be filtered out. All right, Antara and Rory, no more questions from our audience. Antara, would you like to kick us off as we close things out?
Yeah, thank you, Cody, for having us, and Techstrong for giving us this opportunity to present on Serverless. We had a great time. And if you guys have any follow-up questions, feel free to reach out either to me or Rory, or use the resources that are part of the handout section. And we are happy to help and show you the capabilities of Datadog and AWS.
Yeah, I'd just echo it. Thank you very much, Cody, for the opportunity to present. It's been great. I think hopefully we've managed to give you an idea of some of the things you can do with serverless, some of the flexibility and functionality you've got with it, and also some of how you can really kind of like make sure you're managing it to the best effect using solutions like Datadog.
Awesome. Well, Rory and Tara, thank you both so much for joining me. It was such a pleasure getting to speak with you beforehand, and such an honor to hear from you for the last 55 minutes. So thank you both so much for being here.
Thanks very much. Have a good day, everyone.
Of course. So I would like to give one final shout out to our sponsors, AWS and Datadog. Thank you so much for sponsoring our program today. And to our audience, thank you so much for attending. If you stick around with us for just a moment longer, you will be funneled to our post-webinar survey, and we'd love to hear your thoughts. So don't click that X yet. You'll be funneled right into it. But we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Rory and Tara, thanks.
Cheers.